Hi, everybody. This is Mr. Folly, and welcome to podcast 8.1, where we're going to talk about stoichiometry and how to interpret coefficients from a balanced equation in terms of atoms, molecules, formula units, and moles. Really, we're just going to do grams and moles, so I have that on there. I hope I have this changed the right way. And that's about it. So, stoichiometry is the math of chemical equations to convert from one thing to another. Convert from one substance to another, which I think is actually kind of redundant because that's what convert means. Ding, ding, ding. So, what we're going to do, come on. So, stoichiometry is mathematics of chemical equations. I just said that. So, we need to know if we start with 50 grams of salt and 3 crackers. How many Cheez-Its will we get? Oh, look at the little adorable mouse. Oh, so that's kind of the purpose of it. We want to be able to predict stuff. Stoichiometry needs a few things: a balanced equation, and a given amount in grams, liters, or concentrations. And that's it. So let's take a look at a sample one. So what we're going to do is we are going to have an initial, which is your starting amount, the change, which is based on coefficients, and then we're going to have an ending value. And it's going to be equilibrium in a few more chapters, but you get the idea. And you need to know that the word excess means extra. That means you got so much of it you don't care if you lose it or not. So we have excess talking of what Marco says in class. He doesn't need to say all of it. We have enough. We never need to worry about it. We know there's plenty. So if I have 1 mole of CH4, how many moles of O2 are needed? So my initial amount, if I have 1 mole of CH4, that means I don't have any of these others. Okay? So if I give you one value, the other ones are going to be 0, and that should be pretty easily implied. The change is going to be minus 1, my coefficient is 1. This right here would be, minus 2, which is this is where I now get into, this is where I now get into the tricky part of how much do I need. This is the hardest question. Doesn't it mean I started with that? So if one of these is going to change, right, I need twice as much of this to change. Okay? So really what says how much is needed, that really means I could say how much is needed initially. Ooh, I used a fancy multisyllabic word. Okay? And this would be minus 2. This would be plus 1. And this would be plus 2. Why 1? My coefficient is 1. Why 2? My coefficient is 2. Okay? So this means if I have 1 mole of CH4, how many moles of O2 do I need? So if I'm going to use all one of these, I'm going to use 2 of those. Okay? A bad choice for a first one to do, but that's all right. We'll do it. So do you see why I need 2 moles? I didn't even write the word 2. 2 moles of O2 are needed. So the coefficients 1, 2. So I'm going to use 2 to use 1. If I have 2 moles of O2, how many moles of everything forms? Okay, 2 moles of O2, I'm going to add in here and excess CH4. I apparently didn't save my changes when I redid this, so oopsie. So if I have CH4, my initial amount is excess. And for excess, oh, I'm so clever. I use excess for excess. Oh, YNR. Oh, now you're SMH. Excess CH4 means I have more than I need. If I have 2 moles of oxygen, how many moles of everything form? So here if I have excess, the change will be minus. If this, the first thing I should look at is the number that I have. I'm going to use all of this. Minus 2. This is going to be my all. Excess is minus 1, which is going to be some. If it's excess, you're going to have some left over. In the end, I'm going to have excess of this. I'm going to have none of this. Okay. Now the change here, if I lose 2 of this, it's a 2 to 1 ratio, right? So I'm going to gain, it's a product, 1 CO2. And I guess I don't need CO2 there right now. It's in that column. Whoa. And I'm going to gain 2 of H2O. So in the end I have 0 plus 1 is 1. 0 plus 2 is 2. 2 minus 2 is 0. excess minus 1 is still going to be excess. So how many moles of everything form? I'm going to end with 1 mole of CO2, 2 moles of H2O, and 3 moles of total. Okay. If I have 2.58 moles of O2 and excess CH4, so do my ice diagram again. Do. So if I have 2.58 moles of O2, and remember we're going to have excess, how many moles of CO2 form? So originally I'm going to have 0 and 0. The change is going to be, really it's going to disappear. Okay, I guess I'll write this down again. 2.58, excess, 0 and 0. I'm going to do minus 2.58, which is all. This is going to be minus half of 2.58, which is 1 point something. I put my calculator on the wrong side. But half of that so 1.58 divided by 2 is quick go to. 1.58 divided by 2 is 0.79. So why is it disappearing again? Very interesting. So I have excess of this, 2.58, and then half of this, 2.58 divided by 2, is 1.29. Okay? And then the amount that's going to form here is going to be plus, this coefficient is 1, so it'll be the same as this one, 1.29, and plus double, which will be what that is, 2.58. Boy, that is really a bizarro mystery here. This will still be excess, or excess. This is going to be 0 in the end. Get back here. So this is excess. This is 0. This is going to be 1.29. And this is going to be 2.58. If anyone can tell me why these numbers are disappearing, I would be interested in hearing it, but I don't know. So that would be the answer, 1.29 moles of CO2, 2.58 moles of H2O. If I have 15 grams of NH3, how many grams of H2 form? Okay, so we will get to the ice diagram, but first we're going to go to moles. So I'm going to start with 15 grams of NH3 times dividing bar, and I put grams of NH3 on the bottom, and I go through moles of NH3. So the number of grams that I have, little g stands for grams, and little g stands for go to the periodic table. So the periodic table tells me that nitrogen's 14, hydrogen's 1, so add them all up, and I get 17.04. So I'm going to have 15 divided by 17.04. Whoops, I put 1 4. 04 is going to be 0.88 moles of that. So I'm going to do an ice diagram now. Hopefully it won't get all crazy on me. Now here I'm like, oh, this isn't balanced. Oh, how evil. Okay. So when I start, I have 15 grams. How many grams do those things form? 0 and 0. The change here is going to be minus 0.88, which is all. Here it's going to be, do you see how I'll get 3 halves of it? So 3 halves of 0.88. I'm going to put a number in there for that. So 0.88 times 3 divided by 2. Say you get 3 for every 2. It's going to multiply it by 3 halves, and I'm going to get 1.32. I'll put a box around that because that's the one that I like the best. And over here, this will be, so the coefficient here is 1. It's going to be half as much. Okay, so 1 half of 0.88 is 0.44. Woohoo. So then in the end, this is going to be 0. This is going to be 1.32 because 0 plus 1.32 is 1.32. And 0 plus half of 0.88 is 0.44. Okay? And now I'm in moles, right? If I have 15 grams, how many grams of hydrogen will form? So now I'm going to have to go to grams. So I have 1.32 moles of hydrogen. So I'm going to do 1.32 moles of H2 times dividing bar, 1 mole of H2, and 2.02 grams of H2, which I got that from going to the periodic table. And I do that math, and I wonder why my screen changed. And I got 2.67 grams of H2. Okay? Makes sense? Oh, yes, makes lots of sense. All right, if I have 7.5 grams of NH3 react and 0.95 grams of H2 form, what is my percent yield? So now we've got to do percent yield. Remember, percent, as always, is part over total times 100%. So 7.5 grams of NH3 times dividing bar, and I had 17.04 grams of NH3 and 1 mole of NH3. So 7.5 divided by 17.04 is 0.4401. Whoa, where'd it go? 0.4401 moles. So, oh, I remembered balancing this. You tried to trick me again. So 0.4401. So ice diagram. Okay. Initially I have 0 and 0 of this. Initially at the start I have 0.4401 moles. My change is going to be minus all. Okay. So again, this is 3 halves. Hydrogen is 3 over 2. 3 of these come from 2 of these. So it's going to be 3 over 2 times 0.4401. And this one is going to be 1 over 2 times 0.4401. So my real answer here is going to be 0.66. And my real answer here is going to be 0.22. Okay, and that's going to be the answer in the end. In the end, I'm going to have 0, 0 plus 0.66, 0 plus 0.22. And then I need to figure out, I need to convert 0.22 moles of hydrogen into grams, which 1 mole of hydrogen, go to the periodic table, is 2.02 grams of hydrogen. So, whoops, 0.22 times 2.02 is 0.444. Okay, so that stinks because I messed up my math. So if I said 0.95 grams form, I'm going to change this because I'm a cheater. I'm going to change this to 0.35 grams form. Okay, oopsie. All right, so when I do this, to remember percent is part over total, the part that I got was 0.35 grams. That's part. Total I should have gotten was 0.44 times 100%. So 0.35 divided by that answer is 0.788, or 78.8%. Whoops, guess I didn't do the percentage on there. This is my answer. Okay. Yeehaw! All right. I think I did enough of those. So we'll do some more of those later in class. Review mathematics of chemical equations is stoichiometry. Initial, start, change. At the end, grams to moles to ice to grams, percent is part over total, and that is it. Toodles.